Hey guys, my name is Nicole Mashburn and I'm going to give you a short lecture on body water. Now, this will go hand in hand with the one Dr. Ansardi does called body fluids, so maybe a little overlap, but hopefully between the two videos you will have a really good understanding of body fluids and their compartmentalization and how they work. This is not covered until chapter 26, but it's kind of important to talk about at the beginning. So like I said, between this video and the one you'll see called Body Fluids with Dr. Ansardi, hopefully you'll have a good understanding of the fluids inside your body. Okay, so we actually have water inside of our body, good old H2O, and we have about 40 liters. It's about 60% of our body weight is water. And we divide that water into different compartments. We have an intracellular, or ICF compartment, which means inside the cell. Inside the cell. And we have extracellular fluid, about 15 liters, or 25% of our body, and that's outside the cell. So extra, outside, intra, inside. Now that extracellular fluid can be divided into two additional compartments. The interstitial fluid and the plasma. Interstitial fluid is basically the fluid that kind of bathes the cells. So it's outside the cells, it's just in the tissues kind of bathing those cells. The plasma, that's the watery part of blood. So you have blood and it's composed of plasma, which is the watery part, and then the blood cells, red cells and white cells. You also have some other extracellular fluid in your lymph, which is that pipe system that's not your blood vessels that kind of carries your body water throughout your body. We talked about that when we talked about the different organ systems. In your cerebrospinal fluid, so inside your brain and spinal cord. The fluid inside your eye is some extra fluid. Synovial fluid, which is the fluid inside your joints. And there's some gastrointestinal juices as well. So body water, you have it inside the cells, your intracellular. Each cell is filled with cytoplasm, which is mostly water, and then the water that surrounds the cells, your extracellular fluid. Now, body water content changes through your development. Children or infants, they're just about all water. 73% or more of infant weight is due to water. Primarily, they have low body fat and low bone mass, so they're mostly water. As you mature and get bigger, that percentage goes down. In males, it's about 60%, and in females, we're about half water, and that's because we have a higher fat content and less muscle mass. And as you get older, that water amount tends to decrease. You're about 45% in old age. Girls, you probably, if you're my age, in your 40s, you may already be noticing that. Your skin's starting to dry out. So you kind of already know that you need more fluid. Your hair seems dry, your skin seems dry, and you are. You just have less water than you did when you were younger. So where do we get that water? Well, water intake. We have to balance what we take in and what we put out. Our water intake has to balance our water output. And basically that's about 2.5 liters or 2,500 milliliters a day. Now, you know, that good old thing, 8 glasses of water a day is probably not too far off. When we get that water, the way we get that water is through our drinks, our beverages, our food. Food has water, think watermelon, or apples, oranges. Pudding, anything that you eat that's moist has water in it. And we also make our own water. Some of the chemical reactions in our body, the byproduct is water. So it's just called metabolic water. So it's kind of a result of some processes going on in our body that we actually make our own water in our body. So that's how we get our water in. Now, how do we get rid of it? How's the water go out? You guys know urine. When you urinate, that's mostly water. We also have just what's called, sorry about that, had an interruption. Okay, so urine is water output. And we also have what's called insensible water loss, basically through our skin and lungs. So when you breathe out, think of on a cold day, you breathe out that fog that you see, that's water. Like I said, your skin is moist, you're losing water through your skin. You also sweat, perspiration. So if you're too hot, you perspire. So that's water loss. Get my pen back. And you also have water inside the feces. So when you go to the bathroom, have a bowel movement, there's water included in that. If you have diarrhea, there's more water than if you're constipated, where there's less water. So this is just a nice schematic to kind of show you where that water is. So here's your intake. Most of it is from what you drink. There's some food water, and there's metabolic water. Now these change. This is totally dependent on what you do, how much you eat, how much you drink. Your metabolic water, that's pretty constant. You're going to be making water regardless of how much you eat or drink based on the chemical reactions going on in your body. To get rid of water, urine. The insensible losses of your skin and lungs, feces and sweat. Again, this one changes and these change. The more you drink, the more you urinate. If you have diarrhea or constipation, that changes the amount of water you lose in your feces. If it's a hot day, you sweat more. But the water that you lose in your skin and lungs stays about the same. That doesn't change a whole lot. All right, so water is important because it's the universal solvent. All of our reactions occur in water. What's dissolved in that water, or what's part of that water, our body water, are the solutes. What's basically the stuff that's kind of floating around inside the water. They can either be non-electrolytes or electrolytes. Now, your non-electrolytes are those organic things. Talked about that in chemistry. The things that have a carbon, like glucose, fats, lipids, urea, things that are considered organic. They don't dissolve. If you put those in water, they just kind of stay there. They don't really dissociate. Electrolytes are things that do dissolve. Salts, acids, bases. Think about putting a tablespoon of salt in water and you shake it up and it basically dissolves away. So these are your electrolytes. And when you talk about electrolyte balance, you're usually talking about your salt balance. How much sodium, how much potassium, how much chloride, how much of these ions are in different parts or different fluid parts of your body, extracellular versus intracellular. Remember, we get water in through our diet. Salts also come in through our diet. So we basically ingest salts through food and water, or food and drink. Think about Gatorade, has salt in it. And then we lose those salts the same way, through perspiration, our feces, and our urine. So what we're taking in, water and salt, has to be balanced with the water and salt that we're sending out. So when we think about this, one thing, this is kind of a star, make sure you just memorize it. This is just something you have to know. Each fluid compartment has a distinctive amount of electrolytes, or a distinctive pattern. Your extracellular fluid always has more sodium than inside. So you have sodium, potassium, and chloride on the outside of a cell. You have potassium, sodium, and proteins on the inside of the cell. You'll notice there's a charge. These charges are relatively balanced. There's a little bit off. There's a little bit of a charge there, and I'll talk about that later in the nervous system. But for right now, just think of them as balanced, and we'll go into why they're not later on. But right now, just kind of think of them as kind of being a balanced charge. So you have pluses on the outside, negatives on the outside, pluses and minuses on the inside, and they're, just about neutral. But you always have more sodium out here than you have in here. So let's give this an amount. Let's just say this amount is 10 and this is 5. You always have more potassium on the inside than you do the outside. So again, let's just say this is 10, this is 5. Now chloride is your big negative ion on the outside, and it balances with proteins which are negatively charged on the inside. And there's some chloride on the inside. Don't think there's not. There is, but it's not very much. So when we talk about water and water balance, water's always going to go where sodium is. Water likes to follow sodium. And so we're going to watch, as we talk about fluid balance, water balance, we're going to watch sodium, and we're going to think about, okay, water's going to follow that. And that's kind of intuitive. If you probably know it, you just haven't thought about it. Think about Saturday night, it's football game weekend, and you've had pizza and some pretzels, maybe some popcorn. All that's loaded in sodium. Girls, the next day, you are so bloated. You've held on to all that water that you drank to try to keep from dehydrating. So water follows sodium, and that's going to make more sense as we go along. But this is just the first introduction to that, and I want you to just memorize this slide. Know your extracellular concentrations of sodium, potassium, and chloride versus your intracellular concentrations of potassium, sodium, and proteins. So how do we regulate that intake? We got to have some kind of driving force to make us drink. And Basically, that's your plasma osmolarity, which basically means how concentrated your plasma is. So if it starts to drop, think about your plasma becoming sludgy. If it becomes thick, that's a signal you need more water. When your mouth is dry, that's a signal you need more water. If your blood pressure or your blood volume decreases, that's a signal that you need more water. You've got to have more fluid in there to pump your vessels up so that you can keep your blood pressure up. So those are all signals that, hey, we need to be drinking. Once you drink water, that tends to inhibit that need. So you're thirsty, you drink water, you're not thirsty anymore. One way that water works, just putting the water in the mouth actually relieves that dry mouth. It kind of eases those sensors. It also, as you drink, it stretches your stomach, and so there's some receptors in your stomach that say, okay, we're full, we have water, so that tends to make you not thirsty anymore. Water loss. Again, we lose water from our lungs and our skin and our feces, and we lose water through urine. We have to lose about half a liter, or 500 milliliters of water in our urine per day, because you've heard the old saying, we got toxins we got to get rid of. We're going to talk about what those toxins are later, but yeah, you do have some toxins in your blood that you've got to get rid of. And your kidneys basically filter your blood to get rid of those quote-unquote toxins, and in order for that to occur, you have to produce urine. So you will, regardless of what you drink, you're going to produce 500 milliliters of water a day. It's going to dehydrate you if you don't replace those fluids. When you're talking about cardiovascular, the heart and blood pressure, water and sodium play a tremendous role in regulation of blood pressure. So body water and sodium concentrations and cardiovascular events and blood pressure are highly related. Let's think about that. So this is a blood vessel, okay? It's got blood in it. If water starts to leave the blood vessels, okay, there's not as much blood in the vessels, then there's not going to be as much pressure. So one of the things you might want to do would be to maybe retain sodium. If you kept sodium in the blood, that would draw water, because water follows sodium. That would fill the blood vessels back up, and that would increase your blood pressure. Again, we're going to keep coming back to these concepts. This is just a little bit of an introduction today. One of the ways you control water balance is control how much water is reabsorbed by the kidney. And the way the kidney does that is it has to reabsorb sodium. If the kidney reabsorbs sodium, water follows that sodium, and that increases the amount of water you have in your body, or how much water you hold on to. Again, I know these are complicated concepts, but it's just a way to kind of get you started right now. All right, so last but not least, we'll just go kind of reiterate about sodium. It is the most abundant, you got the most of it, cation, or positive ion in your extracellular fluid. This is, let's see, sodium leaks into cells and is pumped out against its electrochemical gradient. And I'm going to kind of skip that right now. We're going to come back to that when we talk about the nervous system. So just kind of skip that. We'll talk about that later. But anytime you change plasma sodium level, the amount of sodium inside the blood, that's going to change the blood volume and the blood pressure. Okay? And when you change blood volume and blood pressure, that will also affect your intracellular and your intracellular volumes. What else am I going to say? So sodium and water balance, again, I think I already said this, is linked to blood pressure control and blood volume control. So this is kind of your key walk-away term. Water follows sodium. If you can remember that, you're going to learn a whole lot about that and remember a whole lot about that when you talk about the cardiovascular system and the kidney. So again, this was just an introduction. You're going to watch Dr. Ansardi's video, and hopefully that's going to help you put these things together. Make sure when you're watching the next video, take some time to think about what happens if you take a cell and put it in a salty solution, or if you take a cell and put it in pure water. So that's just kind of a hint. Be looking for that when you watch Dr. Ansardi's video. And there's some stuff in your textbook about that too. You'll see a red blood cell, putting it in different solutions. Have a heads up on that and make sure you pay attention to how that works. All right, guys, I will see you in another video. Good luck. If you have any questions, I'm always available. Give me a call, email me, come by my office, and see you later. Thanks.